So yesterday, AWS US East went down and took a bunch of the internet with it. And I figured that'd be a great chance to, just completely dunk on a data center not working and prop up how that wouldn't have been a problem had everybody on the world been running peer-to-peer. All jokes aside, downtime is bad. We don't want to have it. And Iroh has a very different story when it comes to uptime. But that story is kind of nuanced. And so I figured I'd take this day in the year of our Lord 2025 to talk about how that difference is expressed, just so we can get to a finer detail on what we actually mean when we say downtime, uptime, and what these things imply. So before we dig into any of that, let's first just clear up what happened, maybe for historical purposes, because I'm sure in a couple of weeks we will have all completely forgotten about this. So what happened? It seems like, looking at the service issue page from AWS, we have us-east-1 endpoints such as IAM, which is Identity Access Manager, and DynamoDB. As far as I understand, DynamoDB powers a lot of stuff inside of AWS infrastructure, and that is part of the reason for the outage. But it was a DNS resolution. There's a long-running meme here. It's always DNS. It's always DNS. Yes, I know that's a joke, but also DNS is really hard. That's the story for another day. Anyways, the point being, if we actually go through the service history in practice what happened and we sort by US East 1, we can see the real core of the issue, according to the incident report, was Amazon DynamoDB in North Virginia not working so well today. Great. Okay, so let's talk about downtime, uptime, and let's quickly outline this problem so that we can talk about why outages are bad. I think it's worth actually just articulating this in a crisp detail so we can get a sense of how this all fits together. Okay, so what do we have? We have boxes on the internet, and you can tell because of the sort of length of this line, we're going to fill some stuff in the middle. But generally the way we think about something is you have an end user device, a laptop, a phone, a tablet, and we have some service. This is an app running somewhere, and we want to connect them together. Great. Okay. The first thing we have is your router. This is the thing that you go to your closet and reset every now and then, and you get very angry when people ask for the password and it's wrong. From there, your router is going to connect to an internet service provider. If this seems like it's overly simplified, that's because it is. But your internet service provider, or your ISP, is going to take that router, take the information from your local area connection and map it to a wide area connection. That wide area connection still has to get to a service, and that service is going to be done by backbone providers. This is kind of the soup of the way that stuff connects to other stuff on the internet. We're not getting into super intense detail here today, but there are a whole bunch of middle boxes that sort of form the way that stuff moves from one internet service provider into the hyperscalers like AWS and GCP and all the other data centers. But from there, you do have an actual data center. There will be some place where data will route into a data center. And from that, it will then route into the service that you're trying to talk to. So that's going to be usually, in this case, a virtual machine running in some faceless rack in North Virginia. And just to get a sense of scale, these numbers are not accurate. So do not quote me on these, but I think it is worth showing just how many of these devices there are deployed in the planet in 2025, just to give a sense of the order of magnitude. So rough estimates using IoT numbers, which is probably some of the better high watermark numbers, is around 20 billion end user devices that are connected to the internet. And then we have somewhere in the order of a rough guess of 200 million-ish routers. So these are home routers. Think of all of the sort of corporate Wi-Fi that you'd be connected to, your hotel routers. That's kind of the family of routers. And so this is we're going from 20 billion down to 200 million. And then moving from our sort of soup of routers around the world into the soup of internet service providers around the world, that's somewhere in the order of 10 million boxes. Again, give or take a couple million. But the idea here is to get into an order of magnitude. Internet service backbone providers, that's somewhere in the order of 10 to 50,000-ish. Again, these numbers are super rough. And then on the data centers, there's somewhere in the order of 10 to 12,000 data center routers around the planet. The service, there's untold number of millions. I actually couldn't find any meaningful data on the services how many sort of internet services there are running in some of these data centers, but it's going to be in the millions. I think it would be bonkers if it wasn't. So we're just going to guess some number of millions. And you can see the problem with the data center failure, right? Because of that choke on the data center count being the lowest thing here, in particular, US East 1 is the default region on AWS. And so a lot of places and a lot of poorly configured services will just go sign up for AWS, provision a virtual machine somewhere in the default region, which is often US East 1. And that will be their box in the cloud and be like, yay, we have a service that's running in the cloud with no redundancy whatsoever. If this is you, turn this off and go get your stuff deployed in another data center. Today was probably a really solid reminder. Yesterday was probably a really solid reminder of that. But, helps to have YouTube remind you that you should have that happen. So we introduce an outage here. And so what happens is, because US East 1 has untold millions of services running behind it, it takes out a really large swath. The data centers themselves represent something of a choke point. So when we lose access to a data center, this is a major league problem. And what do we mean by major league? Often when we talk about uptime, you will hear people talk about it in terms of nines. If this sounds familiar to you, you've probably had the luxury or joy of trying to figure out how many nines you need to have for some agreement. The term how many nines is just what is the percentage of uptime that you are required to have, because it's always going to be 99.9. And so we would call that 3 nines of uptime. With 99.9% uptime, aka 3 nines, you are allowed to be down for roughly 43 minutes a month. A lot of folks these days are aiming for 5 nines or 6 nines. Let's do 5. 5 nines, during the entire month, you get 26 seconds of downtime. If you want 6 nines, that is going to give you 2.6 seconds of downtime per month. This is kind of like, how do we even have time to swap the servers kind of amount of time, right? And so uptime is really difficult. So if you wanted to have this 6 nines of uptime, it's very, very, very complicated to figure out how you even have a service that stays up that consistently. And with something like an outage that lasts 43 minutes on an entire data center that powers a good swath of the internet, and having the whole internet, the whole set of services behind that data center dragged instantly down to the best they can do is 3 nines. Yeah, it's a big deal. People get upset. Now, not to totally toot our own horn, but with Iroh, the number of nines that we can guarantee is actually much easier. And I want to talk to you about how it's easy to get that. It is definitely not perfect, and you definitely can't get 100% uptime, but there's some tricks, and those tricks are worth talking about on a day like today. So the first thing to keep in mind is the failure that you see here is not the only category of failure that you have. Yes, data center outages make the news, but your router needs a reset all the time. And if we think about this and we add this up, there are 200 million routers, them needing a reset. That's probably just like untold number of hours and human suffering for all of the time that Susie broke the router, and having to go and refix your router every whatever. And so that happens a lot. And in the aggregation, it's a lot, but because it's so small a number of individuals that are affected, it's just the people in your house or the people in your hotel, it doesn't make the news. Nobody really cares. But again, in the aggregate, it's kind of a similar issue. It is some break on this wire that is critical for forming a connection. Now, the way that Iroh works, we have to sort of complicate this picture ever so slightly. I've turned the lines purple to indicate it's an Iroh connection, but the service that we use here is actually a relay. And so to talk through how this works, Iroh uses a relay. And the goal in this diagram is actually to connect peer A to the service, which is no longer running on the service column. It is actually an end user device. In this case, we're saying a server running somewhere. This could be an on-prem server provisioned at a office. This could be something running in your closet. Where you have those, you have a lot more options because we can now dial into a lot more interesting places. And the way that that works is peer A and peer B are going to establish a connection to each other through the relay in parallel initially. And so the relay is always sort of the way the connections start. And as quickly as possible, they will discover this direct route between each other. And this direct route actually turns out to be from peer A through their router, through their ISP, to the other router of peer B, and finally to peer B. And so that connection only happens because that turns out to be one of the most direct connections between those two devices. And so in this illustration, they're clearly on the same internet service provider. And so that's an important caveat. This will change if you are in some other data center, if you provision somewhere else. It's going to affect the way that this connection looks. But the idea here is both peers use the relay, and then they connect back to each other. And so you'd imagine, just kind of looking at this, that it would suffer the same problem, right? If you were to sort of nix the connection to US East, then this whole thing would fall apart, right? Doesn't this seem like just the service is the relay and it now suffers the same issues? The only big upside that relays have over any normal service is relays are very dumb. They can only do three things for you in practice. They can help you find out where you are on the internet. They can help you find out where your peer is on the internet. And they can send packets between the peer you're trying to talk to and yourself. Relay them, quite literally. The packets that a relay receives are always encrypted for the other peer, and so a relay doesn't get to know what you're saying to each other, but it does get to know that the connection occurs. But this dumbness, those three things that it can do, mean that the whole design behind a relay is to have lots of them spread around the world. We have, in a standard Iroh network, numerous relays, and there's two reasons for this. When a node starts up, it is always configured with multiple relays, and it always pings them all. And so, classic example, the public networks right now are using 4 relays, and so it will always try to ping all 4. It will collect back those pings from each. It will then measure the latency of the one that came back the fastest and call that one its home relay. If we go back to our situation where now we've nixed a connection to US East, the data center, we will just fall back to US West by default, because what will happen in practice is peer A will try to ping both the relay behind US East and the relay behind US West, and the relay behind US East will never respond. And so its latency will come back with like, dude, it's way too long. And so peer A will just naturally and automatically switch to using US West in the event that US East were to stop responding or were to respond slower than US West. This will also happen for peer B in this case, but it is totally fine for peers to be using separate or different home relays. In fact, that's how it often works when one person is in, say, Europe and another person is on the west coast of North America. That's a really common sort of setup. And so they will have different home relays. That totally works. Once each other has identified each other's relays, the connection establishment happens and the directness can occur based on who's connected to whom. But that's the whole trick. Uptime is now a much easier conversation in this world, right? Because uptime is literally just measured in, hey, is there at least one relay somewhere out there that that peer can connect to with a sort of even remotely useful ping? And as long as it can, what it'll do is use that relay, and it'll just use that for the initial connection setup. So even if it's slow, it can actually fall back to some other geographic region. Peer A could be dialing all the way to Europe for its home relay if we had a whole bunch of catastrophic failures here in North America. And that would just be for the initial packet setup. So you would experience some initial slowness, but as soon as the connection swaps to direct, which happens transparently in the background, you would have instantly a fast connection again. And so in the event of a data center failure, we're gonna get a little bit of extra latency right off the jump, and that will be dependent on where your next closest relay is. But then from there, we're kind of Gucci. We just sort of like go back to business as usual. And this is kind of the amazing thing of having the relay be a really dumb, really interchangeable role. The fact that we can just sort of hot swap these things is the whole magic trick. So yes, we still totally rely on centralized service. And the huge win here is we've designed Iroh to get a nice, fast time to first byte. These connections are competitive with normal internet connections. And the upside here is it's also way more resilient to failure. Isn't that cool? So it doesn't stop there. We can go one step further. We can actually deal with the situation where your router isn't working so well. So, hey, your router needs a reset. Now, we can't connect you to peer B in this case. That's just like straight up not possible because the failure is so much closer to home. The capabilities that we have are much more limited. But you still do have a connection to a router. And so we can use technologies like MDNS and some other local broadcast technologies to say, hey, can we just like go reach out onto our local network and see if there are any peers that we can talk to? And so if you're running an app locally that's like, hey, we don't have any wide area connection, but we do have a local area connection, we can still use tricks on the router in a lot of cases to establish a connection between, say, your phone and your laptop, or your friend's phone and your friend's laptop. You can still be doing all kinds of really awesome, useful work and not have a relay connection at all. And Iroh does need to be configured to do this, but it's totally a thing. And a lot of folks in our community are sort of like gravitate to Iroh for this exact reason. Okay, so it's super tempting to just like dunk really hard on AWS when stuff like this happens and be like, yeah, they're bad at their jobs. How dare they? Blah, blah, blah. But like, it's kind of ridiculous. I think it's actually bonkers that when we go back and we talk about uptime, we have to pull open this like how many nines percentage? We often can forget just how ridiculously cost effective and amazing it is to have services that work this well, this consistently. Instead, I would much rather have us consider the reality that everything on this chain can fail, including DNS, which happens to fail a lot. But you can have failures all over the place. Your router can need a reset. Your internet service provider is down. Your data center is down. Your service is down, which is way more common than your data center being down. And these failures along the way are just kind of part and parcel with the internet functioning. I don't think that we should accept that. We should always work for as many nines of uptime as possible. But whenever a data center goes down, it makes news. But in the aggregate, I think the number of failures that we see around the operation of the internet in the aggregate are way more intense. And so designing the whole system to be more resilient is kind of the whole point. And that brings us to how we handle this. There are going to be failures. There are going to be moments in time where a data center is down, and we can't do anything about that. There are going to be moments in time where an internet services provider is down. We can't do anything about that. The only thing we can do is handle that failure by routing around it. That's the only capacity that works here. So there's some things that just we straight up can't deal with. If your local area network router is borked, you can't talk to the internet. That's just like physics, right? You can do what most of us do these days, which is like, hey, do I still have cellular data? And I'm just gonna route my computer or my phone through that. Or maybe you're doing work on your phone all day from that moment forward. But you will find some other means of running around it. And that is kind of the common characteristic. That is actually how it should be handled down at the technical level as well. And that's kind of the huge win with having relays that are geographically distributed. The failure model is just to route around the problem. And the most critical thing that we do when we think about peer-to-peer is the actual end devices all know how to do that. When we have 20 billion devices that all know how to naturally route around US East failing, that's a more resilient internet. That's a better setup across the board. So that's it for today. In summation, yes, data centers go down, just like every other part of the internet stack. Not all of those parts make the news, but they do all add up to downtime. And the best thing we can do with downtime is anticipate that it's going to happen and find ways to route around it. And so if you like to route around stuff and want to find ways to build more interesting stuff, come hang out with us on the Discord. We'd be happy to chat. We would love to see you. And if you don't want to come to the Discord, that's fine too. I hope you have a lovely day. And I hope you found this entertaining and intriguing. Cool. Thanks a lot.